When you step outside on a clear night and look up, the sky feels alive. We assume those glittering dots are burning right now. This assumption comes from our experience on the ground. When you flip a light switch, the room brightens instantly. There is no perceptible gap between the bulb turning on and the light reaching your eyes. However, light is a physical entity moving through space. The universe enforces a strict, unbreakable limit on how fast it can travel. At 186,000 miles per second, a beam of light circles the entire globe 7 times in a single heartbeat. Because Earth is so small, this travel time feels non-existent to our brains. Since light must physically cross the space between 2 points, your perception of reality operates on a permanent delay. To see the consequences of this speed limit, we have to look past our own atmosphere and out into the solar system. This is our sun, 93 million miles away. Even moving at physics' maximum speed, light from these solar flares takes 8 minutes to reach Earth. If the sun were to suddenly extinguish at this exact second, our sky would not change. Humanity would continue working and playing in the sunshine for 8 full minutes. We would remain in total ignorance until the very last particles of light arrived and the sky finally went dark. There is no way to see the universe as it exists right now. The further we look into space, the further we look into the past. This scale grows as we leave our solar system. This is Proxima Centauri, the closest star to our sun. The light arriving at our telescopes from this star is 4 years old. Our current view of it is already nearly half a decade out of date. The delay becomes even more extreme with hypergiant stars like Betelgeuse. It is a massive, violently unstable sun hundreds of light years away. Because of the distance, the light we see tonight left Betelgeuse centuries ago. It could have exploded while the steam engine was being invented, but because that light hasn't reached us, the star still appears intact. We navigate the night by cosmic ghosts, clear, bright images of stars that may have ceased to exist long before we were born. When we look to the absolute limits of human observation, we find ourselves looking at the beginning of time itself. The James Webb Space Telescope is designed to intercept ancient light that has been traveling toward us since the earliest eras of the universe. This deep space image shows galaxies whose light began its journey billions of years ago. These photons were crossing the void long before Earth formed. Many of these structures have long since burned out or collided with one another. What we see here is a collection of shadows. The night sky is a massive, glowing graveyard of dead stars. Realizing that we are surrounded by a void of ancient dead things can feel overwhelming. It highlights the vast scale of the universe compared to our brief lives, but we can also look at the physical journey of the light itself. As a star reaches its end, it releases a final burst of photons that launch into the vacuum. This light travels for millions of years through the freezing vacuum, drifting past black holes and through the expansion of space itself. Its long journey ends only when it finally physically interacts with a sensor or the lens of a human eye. The information carried across the void for eons is finally processed. The physics of light travel creates a massive, persistent record of absolutely everything that has ever happened in the cosmos. The night sky is a living archive where the actions of stars continue to exist and travel forward, long after the stars themselves have gone completely cold. Nothing simply disappears without leaving a trace.